Okay, so we're going to do number 11 on the back of the review sheet. It says a box weighing 450 newtons, so we're given that the weight is equal to 450 newtons. It's pulled along on a level floor at a constant speed. So constant speed, we're going to write that down because that means the acceleration is 0. It makes an angle of 30 degrees with the floor. If the force on the rope is 260 newtons, so that's what I'm pulling with, so that's an applied force. A push or a pull is an applied force. A, what is the horizontal component of this force? So A would be FAX. B, what is the normal force, F of n? And then C, what is the coefficient of sliding friction? And that's the kinetic of sliding kinetic because it's already moving. All right, so the first thing I'm going to do is I need to draw my free body diagram. Now, before I start drawing any forces on here, I have to establish my sign convention. Why? Because I always have to have the direction in which it's moving to be positive. Because when I apply Newton's second law, that has to be in the direction whenever I'm calling positive. So I'm going to use my standard Cartesian sign convention. Up and to the right is positive, just like I use in math class. And now when I draw my free body diagram, I'm going to draw here, this is my applied force, which I'm having go positive. This angle here was 30 degrees. My frictional force always acts in the direction opposite of motion, and it's parallel to the surfaces in contact. My force of weight acts straight down, and my normal force acts perpendicular to the surfaces in contact. So that's my free body diagram. Now I'm going to look at it, and I'm going to have all my forces need to go perpendicular and parallel to the surfaces in contact. So those are my surfaces in contact. And I'll just draw it to the side so I don't make a mistake. Here's my FA. And remember, from where I start to where I end up, my components are perpendicular to one another. They form a right angle. This is FAX and this is FAY. This is 30 degrees. And remember that this direction is important when I redraw it. So now when I look at this, FAX is equal to FA cosine of 30 degrees. Why is this cosine? Because it's adjacent to the given angle. So FAX is equal to 260 times the cosine of 30 degrees, which is equal to 225 newtons. FAY is equal to FA sine of 30 degrees. Why is it sine? Because it's opposite the given angle. So FAY is equal to 260 times the sine of 30 degrees, which is equal to 130 newtons. So the answer to part A was, what's FAX, which is right here. So I already did part A. Now I'm going to redraw my diagram with all my forces. Remember, my sign convention is important. Up and to the right is positive. I'm going to draw what I had before, so FG is going to be the same. FF is going to be the same. FN is going to be the same. And now instead of FA, I'm going to have FAX, and I'm going to have FAY. Now remember, there's three things that we do in every problem. So now I'm going to go ahead and go down to part B. So for part B, it wants you to find the normal force. Well, the normal force is in my vertical direction, so I'm going to say summation of F of y is equal to ma. Is this block accelerating in the y direction? No, it's not even moving, so this is 0. Now this is the important part. I'm going to look at my free body diagram, and I'm going to look at what's positive and what's negative. So Fn points up, that's positive. Fay points up, that's positive. And Fg points down is negative, and that's equal to 0. Because I want to solve for Fn, I'm going to rearrange my equation to solve for my unknown in terms of my known. So Fn is equal to, and I'm just going to move these on the other side. When I move them on the other side, it changes their sign. So it's going to be F of g minus FAY. So Fn is equal to 450 minus 130. So Fn comes out to be 320 newtons. Part C says, what is mu? Well, mu is equal to F of F over F of N. I just found F of N is 320, but I don't have FF. So the last thing that I didn't do is to find FF. So I'll sum forces horizontally. Summation of F of X is equal to MA. Is this accelerating? No, it's moving at a constant speed. I now look at my free body diagram. What forces do I have going in the X direction? I have FAX, which is positive, minus F of F, and that's equal to 0. So FAX is equal to F of F, which is equal to 225. So I put that up here. My newtons cancel. 225 divided by 320 comes out to be 0.703. Is that between 0 and 1? It is. So then I know I didn't make a mistake. And that's it.